Hi guys, this is Tobias from the Center for Biomedical Imaging at NYU. We are very excited to show you our new open source platform called Mercure, which makes it really easy to deploy machine learning algorithms into clinical practice. And in this video, I'll explain what you can do with the software, and I'll also show you a short demonstration. So Mercure is a DICOM orchestration platform. And orchestration in this context means processing of DICOM studies, routing of studies, and monitoring of studies. And what you can use it for is, first of all, the clinical translation of image processing algorithms. These can be AI-based algorithms, but you can also integrate any other kind of algorithm. You can also use it for the clinical integration of different post-processing tools. It can be very useful for supporting clinical research studies, and there are many other possible applications. So let's make this a bit more concrete. Let's say you have developed a new analysis algorithm that you want to deploy clinically. What you can then do is you can take a Linux server and install the Mercure software on this server, and you can then configure your scanners, your CT scanners or MRI scanners, to send the acquired studies to this Mercure server. And here on the Mercure server, you can define rules so that depending on the type of study that has been performed, your algorithm will be launched by Mercure and the algorithm will be applied. And then the results are pushed into the clinical packs so that the radiologists can look at the results together with the other scans for the patients, and this is happening fully automatically. And in addition to sending studies from the scanners to the Mercure server, you can of course also use a different configuration where you are sending the images to Mercure from the packs, so that the radiologist can press a button in the packs and then the images are sent to the Mercure server, and then the processing is done. And as this figure already indicates, the algorithms in Mercure are packaged as Docker containers. The second use case for Mercure is study routing. In clinical practice, typically not only the packs is used, but people use a number of different software tools and workstations. And it can be quite cumbersome if you need to manually send the studies to all these different destinations, especially if you use a lot of prototypes and if you are quite often adding or removing prototypes. And this is something that Mercure can also automate. So again, you can define rules so that if the scanner sends a cardiac study, for instance, to Mercure, Mercure will send the study into the packs, but in addition to that, it will also send the study to a dedicated cardiac MR workstation. And what's nice here is that you can combine the routing also with processing steps. So for instance, if you work with a third-party provider that is providing some kind of image processing service, and you do not want to give this third-party provider access to your PHI, then you can put an anonymization module in between so that the images will be anonymized before they are dispatched to this service. Now, this anonymization module is something that we're using a lot in our department. In our department, we have a clinical PACS and we also have a research PACS. And it is our policy that no PHI should go into the research PACS. And therefore, we put a Mercure server in between these two systems. And if you're sending a study from clinical packs to research packs, the Mercure server will anonymize the DICOMs, and it will also rename the studies according to a project identifier so that the data in the research packs can be separated by project and it can be separated by PI. And a last example of how you can use Mercure is to utilize it as cloud connector. So if you want to integrate an external cloud service, or maybe you want to use the cloud to collect data for a multi-center study, then you can set up a Mercure server, configure your scanners or packs to send the studies to this Mercure server, and Mercure can then transfer the data into the cloud over an encrypted connection using the DICOM Web Protocol, which is a relatively new protocol that most scanners and pack systems don't support at this point. And again, if you want to, you can anonymize the data in between. So these were some examples of how you can use Mercure. What are the advantages? First of all, Mercure is an open source platform, which means it's completely free to use and you can install it on as many servers as you like. There's also no vendor login. There are of course some commercial solutions out there for AI deployment, but usually if you work with a commercial solution, then you're logged into that ecosystem. And this is somewhat risky because some of these companies might not survive in the long term. If you use an open source platform, you don't have that risk. And it also makes it very easy to collaborate with other sites, because if no commercial vendor is involved, your collaborators don't need to make any agreements with that vendor. They can simply download Mercure and install your algorithm. Then it's very easy to use. It has an intuitive web-based interface. The installation is fully automated. And it really has been designed for non-IT users, meaning that you don't need a degree in computer science to use it. And the last point, it's customizable. It's very easy to integrate algorithms as processing modules, and it's very easy to share these modules. But also Mercure itself can be customized. It has a very modular architecture, and it's mostly written in Python, so it's pretty easy to modify it. Now the processing modules are Docker containers. And this means that you can implement your algorithm using any programming language and using any support libraries or frameworks. We like Python a lot, which of course works very well for machine learning, but some of our modules have also been written in C++, and it's really up to the individual author. There's a very simple interface for the modules that also allows you to pass parameters to the module from the user interface. And we have a number of sample modules available that you can use as a starting point if you want to integrate your own algorithm. Once you have developed your module, you can share your module via Docker Hub. So you can simply upload the container image to Docker Hub, and if somebody wants to use your algorithm, they just have to enter the name of your container image, and Mercure will download the image, it will install the container, and it will also automatically update the container if you publish a new version on Docker Hub. So that gives the end user really an App Store-like experience. The installation is also very simple. There is a fully automatic installation script for Ubuntu 20.04, which is the operating system that we use. But if you just want to try Mercure and play around with it, you can install Mercure in a virtual machine fully automatically just by typing one command. We included configuration files for Vagrant, which is an open source tool for provisioning virtual machines. This works on Windows, Mac or Linux. And to create a test server, you just have to check out our Git repository, go to this subfolder in the repository and then type Vagrant up. And then it will automatically create a test server for you. You just have to wait for 1 or 2 minutes. And what's even better, if you type vagrant-authink up, then it's also including the authink DICOM server, which is an open source PAX, and it will include the OHIF DICOM viewer. So that you have a complete test environment on your computer, which you can use for testing stuff, and which you can also use as development environment. And this is what I will show you now. Okay, I'm now using my Windows computer and I can open a command shell here. And what I will first do is check out our Git repository. After cloning the repository, you can go into the Mercure folder and then in the subfolder add-on, Vagrant and then systemd. And then all that you need to do now is to type vagrant-authink up, and it will now start setting up a virtual machine for your Mercure server and basically install everything. And everything you need to do now is to wait a couple of minutes. The installation has finished now, so I can now open my browser, and the Mercure web interface is now running on port 8000. It's running inside the virtual machine. And on port 8042, we have the web interface of the authink open source DICOM server, which has also been installed into the in this virtual machine. So I will now log into the web interface of Mercure. And since this is the first time I'm logging into this installation, I have to change the administrator password. And after logging into the interface, it's bringing you first to this overview page where you can see the status of the Mercure server. So you can see what the status of the individual service modules is. You can also start and stop individual services here. And by the way, I used now this administrator account to log into the web interface. You can set up additional users by going to this users page here. Now what I will do in this demonstration here is I will install a processing module that performs a segmentation of T1 weighted MRI prostate scans. And this is really just a demo module, so this is not a very sophisticated segmentation algorithm. It's basically a unit-based segmentation algorithm. And yeah, we just developed it to show how easy it is to integrate machine learning models or modules into Mercure, and also how easy it is to share such modules with other users in the community. So the first thing that I will do here, the first step is I will set up a target. I will define where these segmentation masks will be sent in the end after the processing. And in this case, I will send the images to the Auditing server, which is running on my virtual machine here. Now in clinical practice, you would of course send your results to the clinical packs. Now to set up this target, I press the Add New button and I have to select a name. In this case, I will just use Auditing. And now I first of all have to select what kind of transfer I will perform. In the current version that we released, there are two options. You can do a DICOM transfer, or you can transfer the results onto an SFTP server. This is still a little bit experimental at this time. But in our case, we want to send the images over a DICOM connection to Auditing. So I have to enter the IP address of Auditing here. Auditing is running on the virtual machine, and the receiver is running on port 4242. I have to specify the application entity titles here of the sender and receiver. I just use Auditing and Mercure, and then I just press the Save button. And as you can see, the target has now been created, and by pressing the Test button, I can check the connectivity. And as you can see, Mercure can now talk to the Auditing server. So we have set up our target. Now the next step is to install our segmentation algorithm. And to do that, I go to the modules page and again click the install button here. And then first of all, I have to select a name for the module here. I'll just call this prostate segmentation. And then in the next line, I have to enter the Docker tag. So this is the name under which the processing module has been published in Docker Hub. And in this case, this prostate segmentation algorithm has been uploaded into Docker Hub under the name Mercure Imaging /Mercure-example inference. And I just have to press the install button. And now the module has been set up. And this is basically all I really have to do in order to install a new module on Mercure. And whenever this module is used for the first time, Mercure will then connect to Docker Hub and download the container image and install the container image on the server. Now, there are options to do some configurations here. You can press this Edit button and then you can configure some specific settings here, but normally you don't really have to do that. If your module requires certain parameters, maybe your module, you can specify presets or things like that, this can be done on this settings page here. But in this case, I don't have to do anything. Now the next step is to set up a processing rule. So I go to the rules page and again press this Add New button. And I have to first of all give a name for the rule. And again, I will call this rule simply prostate segmentation. And now I have to first of all specify a condition for which series this rule should be executed. And you do that by using DICOM tags. So basically in this selection box here, you can access most of the DICOM tags that are sent or that have been received. And in order to see which DICOM tags are available and which format you should use, you can press this button Available Tags, which shows you some examples here and also shows you all the DICOM tags that are available that you can now use when writing this selection rule. And the syntax, it's pretty much Python, so you can write quite complex selection rules here. And in this example, I will just use something very simple here. I want that this rule should be activated for all MRI studies that are received by Mercure. So my condition here is just that if the modality is equal to MR, then this selection rule should fire. And you can then test this rule by pressing this test button here, which will evaluate whether your rule is valid. And you can also then use this tool to check whether your selection condition works as expected. In this case, it does. Now then, with this control here, you can select what action should be performed if a series has been received that fulfills this condition here. And in our case, we want to do a processing step and then a routing step. So we first want to do the segmentation and then send the images to Auditing. And as you can see, by selecting this option here, an additional tab has appeared here where we can configure our processing step. Now with this trigger option here, you can decide whether your processing should be applied on individual series or if you want to apply it to a complete patient study. And this is necessary because maybe you have sometimes algorithms that don't just require a single DICOM series, but a study like an algorithm that requires multiple contrasts. And then you can specify here which contrasts have to be there, which contrasts have to be arrived, and before you can start the processing. But in our case, we simply want to do processing on a series level. Now on this processing tab, I can select which algorithm should be executed. In this case, just the prostate segmentation. And down here, you can specify whether you also want to dispatch the input images. In this case, I want to do that. Then on the routing page, I can select my target. In this case, that's Auditing. And then another nice thing that you can do here is you can set up notifications. And basically, you can set up webhooks so that you can send notifications into messaging services like Slack or WebEx. And in our case, we, just for demonstration purpose, want to send a notification into Slack, which is running on my computer here. So I set up a webhook under Slack and I can insert the URL here. And there are also like some templates that you can use for setting up the payload. So this is basically all I need to do here. And down here you can specify under which conditions a notification should be sent. You can send a notification when a study has been received, when the processing has been completed, and when an error has occurred. In this case, I leave that as is. And the last thing I can do here is on this information page, I can document information about this rule. So I can basically document why this rule has been set up. So I can write something here like, this is a demo segmentation. And you can also enter a contact email address. And really the reason for this information page is really just so that if you work in a large department, you can document why you have set up this rule, and you can put a contact information here who set up this rule, which just makes it easier to maintain the server over a longer period of time. So I just have to press save, and that's really all that we need to do. So now we have set up our target, we have set up our module, and we have set up our processing rule. Okay, now we are ready to test our segmentation. And to do that, I will now send a demo case via a DICOM transfer to the Mercure server. On the configuration page here, you can see that the DICOM receiver of Mercure is running on port 11112. And I will now send the case from my computer here. I have a few test cases on my computer. These are just prostate scans, T1 weighted MRI scans. And I can send now one case to Mercure using the DICOM Send utility. It's a small utility from the Office DICOM toolkit. And I'm sending this now to the virtual machine on port 1112, which is the Mercure receiver. And it's now sending the images, and the images are now being received. And as you can see, we get a notification here from Slack indicating that Mercure has received the images, and it has therefore fired off this notification. And if you now go to this queue page, you can see that the processing service of Mercure is now running. You can see in this list our study that we have sent to Mercure, and it is now performing the segmentation. It's executing this processing module. And this takes a few moments because in this case, this segmentation algorithm has not been optimized at all. It is not running on a GPU here. It is only running on a single CPU in the virtual machine. So take a moment. And in the meantime, I want to show some additional features here. So if you go to this users menu here on the right side, the first thing that you see here is the help entry, which brings you to the documentation of Mercure. So here you find all the instructions how to use Mercure. And another neat feature here is this option Get Support. If you click this Get Support button here, it will open a chat window directly in the user interface where you can ask questions. And so using this chat, you can get in touch with us if you run into any problems. Okay, as you can see, we have received another notification here from Slack showing that our processing has finished, and you can also see this here on the queue page that the processor is now on idle. And I can now go into the Auditing user interface and look at the patients in the Auditing packs. As you can see, a patient has arrived here. I can click on the case now and open this study in the DICOM viewer that comes with Auditing. And as you can see, on the left side is the input series, and on the right side is the segmentation mask here, which is overlaid to the input images. And as you can see, the segmentation was successful, and it has successfully segmented the prostate. And so, yeah, this was just to show you how easy it is to deploy such a deep learning-based segmentation model to some collaboration site or to install it on a server. It's really, really easy, and everything is happening using this graphical web-based user interface. Yeah, and if you want to see how this segmentation algorithm works, you can go to our GitHub repository. The source code for this segmentation module is, of course, also open source. It's in this repository Mercure-example inference. And the relevant file here is inference.py, so it's a Python-based segmentation algorithm in this case. And this is just really to show you how short this source code is. So if you would remove the comments here, it's probably just 100 lines of code. And what it basically does here is it's basically checking which images have been provided in the incoming folder. It's looping over all received series and then over all received images, and then basically loading the images using the PyDICOM library. Then it's performing the inference of the machine learning model here, which in this case was done using Onyx Runtime as inference engine. And then it's just simply blending the segmentation mask in yellow color here with the background image and writing everything out again using the PyDICOM library into DICOM images. And really, this just showing this to show you how easy it is to integrate your own algorithm into Mercure. And this is really then everything you need to do in order to have something that you can really ship to your collaboration partners and that you can really test in clinical practice. Now, if you want to use a solution like Mercure in clinical practice, you of course need to make sure that it works all the time. And therefore, we integrated 3 levels of monitoring functions. First of all, we are recording the log output of all service modules, and you can review the output on the log page of the Mercure user interface. So this is more for low-level monitoring. Then Mercure also integrates with Graphite and Grafana, which are open source tools for service monitoring, which allow you to create such dashboards where you can monitor the server health. So this is really useful to make sure that your server can keep up with the load of incoming studies, and you can trigger alerts if a problem occurs. And then the third level is the bookkeeper service that we developed. So this is an auditing mechanism that keeps track of every operation that Mercure performs, and this information is stored in a Postgres database. And you can then use different tools like Tableau, or we like to use Redash, to create all kinds of custom dashboards and alerts. So this can be used for creating processing statistics, and you can also use it for data mining. One additional technical detail: there are actually 3 different modes of how you can install Mercure on a server. The first option is to install it natively on the Ubuntu operating system using systemd as process runner. And this is what I just used in the demonstration. And this should give you a high performance, and it's also the recommended way of installing Mercure if you want to have a development environment. But sometimes you are in a situation where the IT department does not allow you to install Ubuntu Linux. Maybe they want you to use Red Hat instead. And in this case, you can also do a Docker type installation, where the Mercure services are running inside individual Docker containers. And this also makes updating very easy because you can simply swap out the containers. And then the third mode is sort of the expert mode. You can also run Mercure using Nomad. Nomad is a workload orchestrator similar to Kubernetes. And using Nomad, it is then possible to run Mercure on a cluster so that you can run modules in parallel. So with systemd and Docker, the processing modules are executed on the same server as Mercure, and Mercure is only running one module at a time. With Nomad, you can run the modules on different nodes of a cluster instead. And you can also define execution constraints so that if you have a certain processing module that requires a certain piece of hardware, these jobs will be dispatched to specific nodes. And you can also potentially run individual nodes in the cloud. Now this setup is a little bit more complex, so if you want to get started, and in particular if you want to deploy your algorithms at collaboration sites, I would recommend that you choose a systemd or Docker type installation. One last thing that I want to show here is our annotation library. We created a Python library that makes it easy to annotate DICOM images if you want to mark findings in studies. Creating DICOM annotations is usually a big pain because there is no single standard that is supported by all DICOM viewers. And the idea of this library is that you can use it in your module to annotate findings, and then the end user can decide in which format the annotations should be created so that it matches to the capabilities of the local PACS system. So it can create annotations in the DICOM SR TID 1500 standard, which is supported by some of the newer DICOM viewers like OHIF. In our department, we are using a PACS by Visage, and therefore we are creating annotations in the proprietary Visage format. And then you can also create annotations as secondary capture DICOM images, so basically burnt in pixels, which can be used everywhere. If you want to learn more about Mercure, or if you want to try it, please go to our website at mercure-imaging.org. You can find the installation instructions there and all the documentation. And there's also this chat button on the bottom of the page. Using this chat, you can get in touch with us and also with other users of the software if you have further questions. We hope that you'll find Mercure useful for your projects, and we thank you for watching.